Hello guys, my name is Dylan. My YouTube channel is Dear Bros, and welcome back to Numerical Integration. Today we're going to be doing Numerical Integration 3. There are two types of integrals. There are definite and indefinite integrals. So definite integrals have a limit and they give us a number. And then indefinite integrals don't have a limit, and they give us a formula which we can use to find this number. And so let's take an integral. So this is the definite integral 1, 0, f x dx, and this can equal a graph, and this is the area under a curve. This is 0, this is 1. This is the area under a curve. This is the number right here, in that area. So that's our review, pretty short review. Now, topic 2 is numerical integration. So let's take the integral that we had, and then we're gonna make a big, like a massive one. It has to be really big. Like that. And then let's draw our curve. Just gonna go whoop. So what we are going to do is we are going to split this into 6 dots. Doesn't have to be perfect, but try to get it as close as you can to even spaces. Okay. So now what we're going to do is we're going to draw our rectangles. As you can see, they're not perfect, but they're good enough that it will still work. Okay, so we have our rectangles. And so what we can do, so this is fx, the peak of the curve. And we can label these, since we did 6 dots, we can go, and well, this is the 6th dot. We did 1, 2, 3, 4, 5, 6 with that final dot in place. And so we can label this as 1/6, 2/6, 3/6, 4/6, and 5/6. And then this is 0 and this is 1, but this can also be said as 6/6. But so what we can do is we can figure out the height as well. So if we draw an integral down here, f of x dx is approximately equal to, and so this is going to be the area. But for the height, we can say, so we need to figure out first, because that's the height. And so the distance between each one is 1/6. And so the answer on the height would be 6/6 for the height. And so our formula can be, so the height, so f of 6/6 times 1/6 plus f 5/6, because the next one's 5/6 times 1/6, and then it's the same thing, so plus f 4/6 and it just repeats itself over and over. Until we get to f 1/6 times 1/6. And so this is our second topic. So let's move on to topic 3, which is our final topic. So this is numerical integration, example 1. So this is our first example. So let's consider f of x equals x. And this is called the identity function. So f of 3 would equal 3. So the identity function basically gives whatever you put into it the exact same. So f4 equals 4. And for example, f pi equals pi. And we can make it even more complicated for f 1 over n. And this still equals 1 over n. So what we could do is we could make the same graph that we did before, but much larger. And let's go that. And yes, this is not a curve, but it is a 50-degree angle, even though it was supposed to be 45, it's 50. It's okay. It's okay if the angle's not perfect. But so, what we're gonna do is we're gonna put 10 dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we're gonna make our rectangles. So this bit just really repeats itself. We're just making the rectangles. But this time we're gonna use n. So on here it's 0, and then 1 over n, 2 over n, 3 over n, 4 over n, 5 over n, 6 over n, 7 over n, 8 over n, 9 over n, and then 1, which equals n over n. And so this is fx, f of x. And so first of all we need to determine the height, which is f n over n. But here, we can make our integral. And it's 1 and 0. It's f of x dx equals the limit over n is the same as infinity. Then we have the summation n k equals 1, and then f of n over n times 1 over n. And so this equals the limit of n is the same as infinity, and then the summation is the same, and k equals 1, and then it's going to be k over n times 1 over n. And so this equals the limit over n is the same as infinity, and then 1 over n squared, summation n k equals 1, k. So this equals to the limit over n is the same as infinity, 1 over n squared, summation n, k equals 1, k. I'm sorry, I wrote the same problem again. But we now have the limit of n is the same as infinity. 1 over n squared. And then instead of the summation, it's 1 plus 2 plus 3 plus 4 until you get to n. And so the next step for this is going to be the limit. So this equals the limit n is the same as infinity. 1 over n squared. And then what is 1 plus 2 plus 3 plus 4 all the way to n? It's the problem that we got in our previous videos, n minus 1 over 2. And minus 1. Yeah, it's a plus. And so, and then it equals the limit of n equals infinity. 1 over n squared. N squared plus n squared. And so this equals 1/2 the limit over n equals infinity. 1 over n squared times n squared plus n over 2. And then this equals 1/2 the limit over n is the same as infinity. N squared plus 4 over n squared. And so this equals 1/2 the limit over n is the same as infinity. N squared over n squared plus n over n squared. And so what we can do is we can make it so that it's n over n times n which these two cross out. So this equals 1/2 the limit of n is the same as infinity, and then this equals 1 plus 1 over n, and then this equals 1/2 1 plus n, because 1 divided by n equals n, and then this equals 1/2. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.